Today's notes is intro to sequences. So let's start off with a definition. It says a sequence is an ordered list of numbers or objects that follow a particular pattern. So let's go ahead and highlight that vocabulary word. We're going to go with the word sequence. Basically, a sequence, it's in order, but more importantly, it follows a particular pattern. Okay, so it's going to keep doing the same thing over and over again, and it's on us to try to figure out what that pattern is. Just to make it easier on us, we describe a term as one of those objects inside the sequence. Okay, so the things that are actually in the sequence, we call them terms. So they have a little quick example over here. Here's our sequence. I have 3, 5, 7, 9. There's a pattern going on here. And every single thing's inside that pattern we call terms. So this one is the first term. This is the second term. This is the third term, fourth terms, and so on. And these three dots mean that this thing keeps going on forever. Okay, as far as terms, we can also change the wording. We can call them terms, elements, or members, but honestly, in this class, we're probably going to call them terms. So here's a couple of examples. Let's go ahead and take a look at what this says. On the first sequence, I have this pattern here, and it's up to us to try to figure out what's going on in this pattern. I noticed that I started off with one block, then I went to 3, 5, and 7. It looks like it keeps adding 2 extra blocks each time, and it's adding it to the right. So I'm going to write there's 2 extra here, and then they put 2 extra more over on the right side. I'm talking about these two on the right. Then they put another 2 on the right. So if they were to do the next one, I would assume that there's another 2 right here on the right, right? So every single time, we're just going to go 2 extra, 2 extra, 2 extra. So what pattern do I see? I see that they keep adding 2 squares on the right. Okay, if I were to write out the next 2 terms, what would that look like? Well, I think on let's see, let me just make sure. This is the first term, the second term, the third term, the fourth term. So when I did the fifth one, right, when I do the next one, the fifth term, it's going to add 2 extra squares on the right to the fourth one. So I need to draw this one again. But this time, instead of 1, 2, 3 blocks going up, I'm going to do a fourth block over here. So let's see, I'm going to put a little square on the bottom, and then I'm going to go 1, 2, 3, that extra fourth one over there, and then I think that's what my fifth term is going to look like. If I were to do the sixth term, it would do the exact same thing as the fifth term, right? I'm going to draw this again, but then I'm going to have an extra block over here. So it'd be 1, 2, 3, 4, 5 blocks or 5 little stacks. So I need to draw a little box, and then I'm going to do 5 stacks. 1, 2, 3, 4, 5. Okay, so there is my first example. Let's take a look at the next one. What about the sequence that goes 7, 11, 15, and 19? What kind of pattern am I seeing there? Well, it looks like each time it's adding 4. And from 11 to 15, they added 4 more. And from 15 to 19, they added 4 more. And it's going to keep doing that. So they keep adding 4 more each time to the previous term, right? So if I were, let's see, let's make sure this is my first term, second term, third term, fourth term. If I were to write out my fifth term, then the fifth one is going to take that 19 and it's going to add 4 more. So I think the fifth term is going to be 23. And if I were to look at the sixth term, well, then it's going to take the one before it, which was the 23. Then it's going to add 4 more, and it's going to become 27. All right, let's take a look at the next one because the next one changes a little bit. I want you to pretend like, hey, I went from 5 to 10. So I think most students right away, they're going to say, oh, they're going to add 5 more. But if I add 5 more again, this doesn't work, right? 10 plus 5 is 15. It doesn't equal 20. So the pattern is not that they're adding 5. In this case, the pattern looks like it's like they're doubling each time. So we're going to multiply by 2 because 5 times 2 gives me 10, and then 10 times 2 gives me 20. 20 times 2 gives me 40, and it looks like this is working out. Okay, so just because you see something works for the first one, you got to check to make sure it works every single time. So what's the pattern? This thing keeps multiplying by 2. And how do I get the fifth term? Well, the fifth term is going to take the one before it, which was the 40. It's going to multiply it by 2, and it should be 80. To get the sixth term, I'm going to take the one before it, which was the 80. I'm going to multiply it by 2, and it's going to give me 160. Okay, so that's what a sequence is basically a set of patterns, and then we just kind of try to figure out like what's happening with those patterns and how can I continue this pattern to get the next elements, okay? Since sequences can get really large, because remember that this thing has a dot, 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 that means this thing goes on forever. So I'd go times 2, times 2, times 2, times 2, and I can keep on doing this forever. So since sequences can get really large, it is beneficial for us to have a way of writing the terms using a shortcut. Often you will see the use of subscripts. Let me zoom in because I didn't give myself a lot of space there. Subscripts. A subscript is a little number written on the bottom. So for example, well, you'll see it right now. So we're going to use subscripts to identify the terms in a faster way. And that's going to be one of our vocabulary words. So let me go ahead and highlight that. For example, instead of writing the first term, a faster way to be write this thing as a sub 1. When I say a sub 1, that doesn't mean a times 1. That means your first term. It's just the first one in the list. Similarly, to write the second term, we can instead write a sub 2. Again, that doesn't mean like take a and multiply it by 2. It's just giving it a name. It's just saying your second term, okay? That 2 really doesn't have a value to it. It's just telling you like, hey, it's the second one on the list. And then obviously for the third term, we're going to write a sub 3. Again, not that it's 3 times bigger, just it's the third thing on my list. So for example, going back to the original example right here, this would be my first term, so I can write this as a sub 1. This would be my second term, so I can write this as a sub 2. I can say my second term is equal to 5, okay? It's just a way of listing stuff for you. All right, let's go ahead and go finish up these examples. It says, for the following sequences, find the first term, the fifth term, and the sixth term. So really, really easy in the very beginning. They're going to say, hey, find the first term. Well, here's 14, 11, 8, and 5. The first term, they already told me what the first term is. The first term, it's just 14. That's the first one on the list, okay? Done with the first part, right? Now, as far as the fifth term, the first, let's see, I got first term, second term, third term, fourth term. They did not tell me the fifth term. I need to figure it out. All right. So if I'm going to figure it out, I'm going to try to find the pattern. And in this case, it looks like I'm subtracting 3 each time. Yeah, that looks like it's working. So if I wanted to get the next one, which would be my fifth term, I would take my 5, subtract 3, and get an answer of 2. And they're asking for my sixth term. So to get my sixth term, I would take the one before it, which would be the 2. I would subtract 3 more, and I would get a negative 1. And that takes care of my first example. Let's take a look at the next pattern. I got a 4, 12, 36, and 108. To go from 4 to 12, I can add 8. But if I add 8 more, that gives me 20, and that's not working. So I need to get to 12 a different way. If I were to multiply by 3, 4 times 3, that gives me 12. 12 times 3 gives me 36. 36 times 3 gives me 108. Looks like this is working. I should have done the easy question first. What's the first term? Well, that's easy. The first term is just 4. So far, I have the first 4 terms. I want the fifth term. If I want the fifth term, I need to get the one before it, which is 108. I need to multiply that one by 3. When I do that, I get 324. And to get the sixth term, I need to get the one before 8, which remember, we're at 324. I'm going to multiply that number by 3. And what I get is 972. And I am done with example number 2. All right, let's do the next one. First term is easy. The first term is 4. Second term, how do I go from 4 to 15? Well, I can add 11. Um, And let's see if that's going to work. If 15 plus 11, that's going to give me 20. Yeah, it looks like this one's going to work. So let's just verify. If I add 11, it gives me 15. If I take 15 and add 11, I get 26. If I get 26 and add 11, I get 37. Looks like this is working. So every single time, I'm just adding 11. So if I want my fifth term, I'm going to get the one before it, which was 37. I'm going to add 11 to it, and that's going to give me a 48. If I want my sixth term, I'm going to add 11 to the previous term, which is 48. Mess that up. Let me go and fix it. 48. Add 11 to that, and that gives me 59. All right, we got two more examples, and then we can move on. From 80 to 40, I can subtract 40. But if I subtract 40 again, I get 0, and that's not working out because I'm trying to get 20. So what's another way I can jump from 80 to 40? Well, I can divide this by 2. 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. So it looks like this is working out. I know my first term is 80. My fifth term, I need to take the one before it, which is 10, divide that by 2, and I get 5. My sixth term, I need to take that 5, divide that by 2, and there's a couple of different ways you can write this. You can either write this as an improper fraction, because this is going to give me a decimal. It's either going to be written as a fraction like 5 over 2, because remember that fraction means divide, or I can write it as a decimal. When I divide those two, I get 2.5. And I forgot to write the pattern. This is divide by 2, divide by 2, divide by 2. All right, this next one looks really weird because I have a 1/2, then a 2/3, then a 3/4, then a 4/5. So what's the pattern here? Well, there's a couple of different patterns that you can see. Um, some students will say like, oh, just keep zigzagging, like, oh, go up, go down, go up, go down, go up, go down. There's actually an easier one. All we're gonna do is we're gonna add 1 to the top and bottom. So for like, let's look at the top. On the top, if I add 1, I get 2. If I add 1, I get 3. If I add 1, I get 4. Same thing on the bottom. If I add 1, I get 3. If I add 1, I get 4. If I add 1, I get 5. So we're just gonna add a 1 to the top and the bottom. Add 1 to top and bottom. Now that I know the pattern, I'm going to go ahead and write that my first term is a half. My fifth term, let's see, I need to take the 4 over 5, and I need to add 1 to the top and add 1 to the bottom. That's going to become a 5 over 6. In my sixth term, I'm going to take that 5 over 6, and I'm going to add 1 to the top and the bottom. It's going to give me a 6 over 7. All right, and we're down to our last four examples. It says sometimes the general form of a sequence is known for the nth term. So we're going to highlight this general term because that is going to come in useful, especially later on. Right now, we're going to use it a little bit, but man, later on, this thing's going to give us some trouble. So for the nth term, when this is true, we write the general form using braces around the formula. We're going to be using these braces to let you know, like, oh, this is the general formula, and it's going to allow you to get all the terms right away. For example, when I say b sub n is equal to 2n plus 1, this would represent the sequence b1 equals 3, b2 equals 5, b3 equals 7, b4 equals 9. Why is that true? Well, because all we're doing is we're taking our n. You see that n is 1 in this case? And I'm just going to plug it in. 2 times 1 is 2. 2 plus 1 is 3. So my n was 1, the answer was 3. We're just almost like function notation. We're taking that number, we're plugging it in, okay? For my second term, you see my n is 2. Anywhere I see an n, I'm going to replace it with the number 2. So 2 times 2 is 4. 4 plus 1 is 5. That means my second term is going to give me a 5. All right, let's just go ahead and start cranking these out. I think it's the more you see it, the more it's going to make sense, okay? It says use the general form of the sequence below to list the first 4 terms. I want the first 4 terms. That means I want my first term. Notice that when I did my first term, my n was 1. Whoa, I don't know how that happened. That was kind of cool. I'm going to try to want to do that later again. It's not going to let me. So when my 1 was n, I'm going to take my 1 and replace it wherever I see an n. So since this is my first term, I'm going to go 6 times, there's the n, I'm going to replace it with the 1. The answer I get is 6. Okay, let's do the next one. For my second term, this time my n is 2. Whoops, wrong one. So anywhere I see an n, I'm going to replace it with the number 2. So this is going to be 6 times 2, which is 12. For my third term, now my n is 3. Anywhere I see an n, I'm going to replace it with the number 3. That's going to be 6 times 3, which the answer is going to be 18. And then for my fourth term, now my n is 4. Anywhere I see an n, I'm going to replace it with the number 4. That's going to be 6 times 4. The answer is 24. So if I were to write out my sequence, the first term was 6, the second term was 12, the third term was 18, the fourth term was 24, and I can keep doing this forever. So I'm going to put a dot, dot, dot. That's what my sequence looks like. Okay. All right, let's do the same thing, but this time for my B sequence. I want the first 4 terms. So my first term, anywhere I see an n, I'm going to replace it with the number 1. Well, right there it says negative 2 times n. So I'm going to write negative 2 times 1 plus 15. Negative 2 times 1 is negative 2 plus 15. That gives me a positive 13. So I know my first term is 13. Let's take a look at b sub 2. My second term, anywhere I see an n, now my n is 2, so I'm going to write negative 2 times, there's my n, I'm going to replace it with the number 2 plus 15. Negative 2 times 2 is negative 4, negative 4 plus 15 is 11. When I do b sub 3, or my third term, you notice I've been saying it really fast. I've been saying b sub, because sub means subscript. That just means the little number on the bottom. Okay, so b sub 3, or the third term, is equal to negative 2, there's my n, I'm going to replace it with the number 3 plus 15. Negative 2 times 3 is negative 6 plus 15 is 9. And then b sub 4, or my fourth term in the sequence, I got negative 2 times 4 plus 15. That's a negative 8 plus 15, which becomes a 7. So if I were to write out my sequences in order, my first term would be 13, my second term would be 11, my third term would be 9, my fourth term is 7. Dot, 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 and this sequence keeps on going. All right, we got 2 more and we'll be done. Let's go ahead and try this one. This time, my sequence, I did it again. I don't know how I did it. I'm so upset. This time, my sequence, I'm going to go ahead and plug in the n right up there. This is going to look a little weird, but let's see if we can figure this out. This is going to be c sub 1 equals, this time my n is 1. So I'm going to write 2 to the, there's my n, 2 to the first. 2 to the first is just the number 2. My second term in the sequence, this time my n is 2. So this is going to be equal to, that's not what I meant to do. This is equal to 2 to the second power. That's a 2 times 2, which is 4. When I do my third term, anywhere I see an n, I'm going to replace it with the number 3. That's 2 to the third. That is not 6. Remember, 2 to the third means 2 times 2, which is 4, times another 2. That's my third 2. Let me write that one out because I don't want you to mess that one up. This means 2 times 2 times 2. Remember that this is 4 times 2, which actually becomes 8. And then the last one, c sub 4, or my fourth term in the sequence, that means 2 to the fourth power. Well, 2 times 2 is 4, times another 2 is 8. And then 8 times another 2, that's my fourth 2, that's going to be a 16. So my sequence looks like 2, 4, 8, 16, dot, dot, dot. All right, last one. I got d sub n is equal to 2 over n. So if I want my first term, I'm going to write d sub 1, which means my first term. I'm not going to use a different colored highlighter. I'm going to go back to green. That's equal to 2 over my n, which is 1. 2 over 1, that's just 2. D sub 2, which is my second term, that's equal to 2 over 2, and 2 divided by 2, that's just 1. D sub 3, or my third term, I'm going to write this as 2 over 3. And 2 over 3 doesn't simplify, so we're going to leave it like that. And then the last one, d sub 4, that's my fourth term. I'm going to write that as 2 over 4. 2 over 4 does simplify to 1/2. All right, so what does my sequence look like? This is a really weird one. It starts as 2, goes to 1, goes to 2/3, and then it goes down to 1/2. All right, those are all the notes for today.